I think I ought to begin by explaining what I do and what I do not do, because there is some misunderstanding about that. I think I am a visual neurobiologist, and most of my career has been spent on studying the organization of the visual brain in primates, let's say humans and monkeys. And is there a problem with the?
No, you need to use the mic.
I need to. Sorry.
I'm just gonna turn it on. Let's see. It's on, but I think you gotta be closer to you.
Okay. Okay. So thank you. So I'm a visual neurobiologist. Most of my time has been spent studying the organization of the visual brain in primates. And it turns out the visual brain in primates is quite a significant part of the brain, perhaps amounting to something like a quarter of the entire brain, if not more. And my incursion into what is called neuroesthetics is really an attempt to understand how a visual input arouses an affective state in us, a state of beauty or fear, of desire, or of anger. So let me just state at the outset that the questions that neuroesthetics addresses are not the questions that are imputed to it. I think some, not artists but some art historians, and not all of them either, get quite upset about the fact that neurobiology is now asking questions about what beauty is. I have never bothered to respond to these criticisms because they impute to me something which I am not doing. Neuroaesthetics does not address the question of what beauty is, nor does it address the question of what art is, nor does it confound art and beauty. It asks a much simpler question, which is, what are the neural systems that are engaged when we experience beauty? This is a very legitimate scientific question, as legitimate a scientific question as asking what are the neural systems that are engaged when we experience colors. And you heard quite a bit about that in a specific context earlier on. And it turns out, of course, that asking such a question allows you to ascertain whether the statements of people, which you cannot verify except by believing them, are true or not, because in the case of synesthesia, color synesthesia, of course, the activation in the color center of the brain is a sure sign that they are not lying to you. And much the same applies to the experience of beauty. But if you want legitimacy from philosophy about the experience of, about the importance of the brain in beauty, you can find it in Edmund Burke, one of the most famous definitions of beauty, which is, beauty is for the greater part some quality in bodies acting mechanically upon the human mind by the intervention of the senses. Now, if you look at that definition, 2/3 of it is really about the brain. Quality in body is about body, but the human mind is, for me, largely the brain, and senses, of course, entirely the brain. Now, people have said to me, but the mind is more than the brain. And again, it's not an argument I would like to go into, because I usually ask them, well, would you concede that 50% of the mind is caused by the brain? Some of them say, oh, well, I'm not so sure. I say, well, all right, 30%. Would you buy that? They say, yeah, we'll accept 30%. That's the 30% I'm studying. The rest I leave to you. So my aims are much more limited than people often assume. But I think you'd find, if you read Immanuel Kant or Schopenhauer or Edmund Burke or those who wrote about in the English Enlightenment about the sublime, and other philosophers like Dewey, you'd find that there is a nod, at least, to the notion that the brain is involved in the experience of beauty. So we nevertheless, in spite of the fact that the questions we ask are very limited and strictly related to brain activity, we nevertheless find inspiration in what the artists do and in what philosophers of aesthetics and art historians and art critics say. And one of the best questions that has been asked in this field is actually by an art critic, namely Clive Bell, the husband of Vanessa Bell, whom some of you may know as an English painter and part of the Bloomsbury group. And he said that, look, if you can tell me what all things which we experience are beautiful have in common, you have essentially solved the problem of aesthetics. And his list is as follows. He said, can you tell me what Santa Sofia in Istanbul and the windows at Chartres Cathedral in France, a Mexican sculpture, Chinese bowl and Persian carpets, and the frescoes of Giotto at Padua, and the masterpieces of Poussin, Piero della Francesca and Cézanne have in common? If you can, then you have solved the problem of aesthetics. Now, this was a very interesting question, very nicely put. So our question was, what do diverse works of art, when experienced as beautiful, have in common? It was a question inspired by Clive Bell's book, Art. But Clive Bell, in his book, Art, does two things. One is he restricts himself to a visual beauty, although he does talk briefly about music and mathematics, but he largely restricts himself to visual art. And we did not wish to do that because philosophies of aesthetics speak of beauty in the more abstract sense. If you look at John Locke or Hume or Plato or Aristotle, they always speak of beauty from diverse sources, poetry and mathematics especially, and music and drama and so on. So we wanted to extend our range to include both musical beauty and mathematical beauty. And secondly, Clive Bell's book was published in 1914, so he was writing really in a world where beauty was equated with art, largely. Now, we are aware of the fact that beauty and art are not the same thing, and the relationship between the two was severed when Marcel Duchamp sent the urinal to an exhibition in New York and threatened to sue the curators if they did not exhibit this. So, let me then summarize that we are interested in the experience of beauty. We're interested in what happens in the brain when people experience beauty. We're interested in what happens in the brain when people experience beauty derived from different sources. And we acknowledge that cultural influences are important in the experience of beauty, but that's also not our aim. We're just asking what do individuals, when they experience beauty, what happens in their brain. It is actually rather like synesthesia in the sense that we just heard that some synesthetics don't ascribe the same colors to the same letters as others. Some see it in yellow, others see it in red, and so on. But whenever they see the things in color, there is activity in a part of the brain. And essentially, it is the identical question, but a different means of approaching it. And it's to do with beauty rather than synesthesia. So the experiment is as follows. You take people, London is the world's great, until now at any rate, the world's great cultural and ethnic city, multicultural, multi-ethnic city, and so you can get people from diverse sources and ask them to view pictures and listen to musical excerpts which they find beautiful and which they rate as beautiful and as ugly or indifferent. And then they come back to the scanner and look at these pictures and listen to these musical excerpts again and re-rate them. And then we look at what happens in their brain when they experience things as beautiful and as ugly. Now, just in case there's anyone who's in the dark about this, the way this is done is to put people in a scanner. When areas of the brain are especially active, their metabolic requirement increases, so more blood is channeled to the area, and the difference between the oxygenated blood and the deoxygenated blood is what is detected by the scanners, and from this you infer, from a change in blood flow, you infer that there is more activity in those areas. So let me show you then pictures which people rated, and the ones which most but not all. We had Chinese and Indians and Africans and English and English Americans and Europeans of different countries. So there was quite a motley variety. So the ones which most people thought was beautiful, not all, but most of them, was the odalisque by Ingres, and this was given a high rating by most people. Most people thought that this by Lucien Freud was ugly. Now this is an interesting point because this is a painting which is worth many millions of pounds, And many people would like to possess it. It projects truth about decadence and decay and much else besides. But the point of the experiment is that this was experienced as ugly. The rest of it is no longer, it's just like in synesthesia. If you see it as red, then that's good enough for me. Musically, I think all of them, regardless of culture and ethnic origin, thought that this was beautiful. So this, of course, is the slow movement from Mahler's Fifth Symphony, and practically all of them rated the next piece as ugly, even though it may have great musical, artistic qualities, which was not audible to them. Which is Ligeti's second violin concerto. So, if you look at the activity in the brain produced by looking at pictures, you of course get activity in the visual cortex shown in white at the back, and if you look at the activity produced by listening, you get activity in the auditory cortex shown in green in the front. But if you ask the question, what are the brain areas that correlate with the experience of visual beauty and of musical beauty, you find that there is one area which is common. It is located, it is here. It is part of the emotional brain, the medial orbitofrontal cortex, and that is the activity produced there when people view pictures which they rate as beautiful, and this is the area which is active when people listen to excerpts which they rate as beautiful, and so there's a common area there which is in yellow. Now, let me say that when with visual stimuli, there were of course landscapes and abstract paintings and nudes and faces and so on, so that there was a diversity of sources within that category, and the same with music. It was jazz and orchestral pieces. So, to go back to the question that Clive Bell asked, which philosophies of aesthetics and art histories and artism have never been able to give an answer to, what is common to all that is experienced as beautiful, we can now give an answer to, but only in neurobiological terms. We can say that what is common to all that's experienced as beautiful is that it correlates with activity in a specific part of the brain, which is of the emotional brain, which is the medial orbitofrontal cortex. Now let's go to another question, again inspired by the discussions in philosophy of aesthetics, and this is this: can an aesthetic judgment ever be quantified? And the answer is yes. So if you look at the medial orbitofrontal cortex with visually beautiful stimuli, you find that the activity there is higher when people look at paintings which they qualify as beautiful than with ones which they qualify as ugly. And the same is true of music. Okay? And the same happens to be true with visual or auditory input, which they qualify as ugly. So with ugly stimuli, you've got activation, especially in a region here called the amygdala, but also in the motor cortex. And again, the activity there is parametrically related. In other words, it is in proportion to the intensity of the declared experience of ugliness, just as with beauty. Now, if one were to look at the writings of Plato, especially the Symposium, I suppose, but many others as well, beauty is always linked to desire. So you see something beautiful, you desire it, be it a person, or be it an event, or be it an object, or whatever. So we thought that we'd look at that to see whether there is any link in the brain that could partially account for the strong link between desire and beauty, or beauty and desire. And so we got people to look at pictures of people or events or objects, and if you discern that they're all Japanese, it is because the study we did this in Japan. So it's again the same way of doing things. You show them pictures of people and they tell you how much they desire these people. I put Mr. Koizumi up there because Mr. Koizumi was a graduate of University College and he's much admired by Japanese ladies. Then you've got events to your left and objects at your right. And again, they have to rate them as to how desirable they are. And then they look at them again in the scanner, and we do the same thing. And you find that I'm not going to go into the activation of other areas, because all I want to emphasize is that the medial orbital frontal cortex, which is activity which correlates with the experience of beauty, activity there also correlates with the experience of desire. And again, the activity is proportional to the intensity of desire, so the more desirable stimuli yield a significantly higher activity than stimuli which are not desirable. I'm going to skip the next one because it takes me a bit away from what I want to explain. So all of this then, so let me just summarize this for you again, that stimuli which are experienced as beautiful, and not everyone experiences the same stimuli as beautiful, but whenever stimuli which are experienced as beautiful, be they musical or be they visual, leads to activity in a specific part of the brain, of the emotional brain, which is the medial orbital frontal cortex. Now, this raises a very, very interesting question, and the stimuli which are experienced as ugly leads to activity elsewhere. It leads to a very interesting neurobiological question, which is, what is it that decides that the activity in medial orbital frontal cortex should be high when you experience something as beautiful and low when you do not? After all, when we look, so we've got now common areas. The primary, this is diagrammatic, so it's not absolutely precise, but you've got the input areas where all the visual input goes. You've got areas which are specific for bodies, and they exist. There are areas of the brain which are especially active when you see bodies. And then you've got the medial orbital frontal cortex and the amygdala. So when you view a picture such as this one, you have activity which goes here, here, and then correlates with activity in front. And when you view a picture such as this, you've got the same common areas up to here, but then these areas active. So something here must decide that signals are routed to these areas. And this is a problem in neurobiology, a general problem, because there's no terminal station in the cortex, and there's no single cortical area which does not have multiple outputs, at least more than 12. So the question is, are all these outputs engaged when that area undertakes an activity, or are they engaged on a selective basis? The evidence for that, I'll show you that they do take a part in selecting the output, but you can reach that evidence without any experiments. You can reach it, for example, by looking at the work of Francis Bacon. Now, Francis Bacon was of course, a very eminent British artist, and I'm just going to go back to the definition of Edmund Burke first, that some quality in bodies, all right? So what did Francis Bacon say he wanted to do? Francis Bacon, in his own words,
I wanted to give me a shock. Now, shock, you could say, is a form of expression. But what expression it is, I don't know. It's a visual shock. It's not a shock about, it's not a shock that you could get from a story. It's just a visual shock.
And he said that to give this visual shock, he had to go beyond the intellect and appeal to the raw emotions.
Because I've made images that intellect would never make.
I've made images the intellect would never make. So to give this shock, what did he do? If you look at all his paintings, which, by the way, the first exhibition was described as a chamber of horrors, And the most recent exhibition, retrospective in London, was described by the correspondent of The Guardian as a visit to private hells. Perhaps for the average viewer, it was best summarized by Margaret Thatcher, Prime Minister of the United Kingdom, who said, when asked about Francis Bacon, she said, "Oh, that terrible man who paints these dreadful paintings." That, I think, summarizes the common view of Francis Bacon. So what did he do to give a visual shock? Now, don't worry about the fact that these paintings are worth millions of pounds. But what he did is he subverted the brain's representation of faces. They're always deformed, and they're very, very much mutilated. And here is another one. And when asked about this violence, he said, "You know, the reek of blood smiles at me. I love it." And then he said, what have I done which is more violent than what you see every day? But these are not interesting because the impact is visual, and the visual impact is of a severely mutilated and distorted faces and bodies. But if you look closely, the objects are not. So here is a perfectly identifiable chair, and here is an identifiable deck chair. It is the bodies that are mutilated. And so, because the brain, in a way, has got a means, it's got a template for what a face should look like. And if you subvert that, you go into the world of horror. In other words, I think it's true to say, now somebody once objected to this, and if somebody else is going to object to what I'm about to say, please go ahead and do so. Most people would not find someone with one eye here and one eye here beautiful. I think it's very unlikely. Now, there are 7 to 9 billion of us, and if you take a bell curve, there might be some who like it. And nor is anyone going to qualify someone with a very short arm and a very short leg on one side and a very long one on the other side as beautiful. I think we need certain proportions before we can even begin to speak about beauty. And that is what Francis Bacon was subverting. And I think that there is a kind of a template in these areas of the brain which tells you that the activity, that what you're looking at is a normal face. And that is the beginning of qualifying something as beautiful. We have got other evidence which I can go into, but I want to show you something much more direct, which is from something generated by a computer, so humans don't have much say in it. So there is an area of the brain, which is area V5, which is especially concerned with motion. And it responds to moving stimuli better than to anything else. It's not interested in color, and it's not interested in shape either. So you can get the computer, by using fuzzy logic and all sorts of other things, to generate a set of images in which there are dots which are moving in different ways, but they're always the same dots, and they're always the same size dots, and they're always moving with the same speed. And here is a stimulus which most people preferred. Let's see if I can get this to move. No, I've got to go back. I think we may have some trouble here. Oh, sorry. What is this? Can someone help me with the Norwegian here? Oh, there. So anyway, this is a non-preferred stimulus for all the subjects. Again, people from different ethnic backgrounds, and this is the preferred stimulus for all the subjects. Again, from different ethnic backgrounds. Let's try this again. Okay, there we go. All right. So, dramatically, in this instance, people from different backgrounds all preferred the same stimulus, rated the same, this one as the best stimulus of the stimuli that they were seeing, that they were shown. And there you find that there is when they look at stimuli which they prefer, there is activity in this area, which is the motion center of the cortex, and there is activity that correlates also with activity in the medial-orbitofrontal cortex, so that there is some selection procedure which allows signals to be taken to the medial-orbitofrontal cortex when they are preferred. And basically that is one of the principal motivations of my work, which is how do the visual areas which I have defined in the past, how does activity in them generate an effective experience in the brain. Now, the philosophers of aesthetics spoke in vivid terms about the difference between the sublime and the beautiful. So there are some things which are both sublime and beautiful, the Pietà of Michelangelo being a supreme example. But in general, there are lots of other stimuli which are not to be qualified as beautiful, but as sublime. Now, sublime has got a very special definition in Kant and in those, I can't remember their name, Burke and the Earl of, I can't remember his name. Anyway, the editor of The Spectator, they defined sublime as beauty from ugliness, or beauty generated from horror, or pleasure from displeasure. So you've got sort of contrasting things, and thought that it was largely created in the mind. And the Scottish and English Enlightenment, those writing about it during the period of the Scottish and English Enlightenment, concentrated upon phantasmagoric landscapes such as Mount Everest or Mont Blanc, or a violent sea storm, which you are awestruck by, but you are viewing it from a distance, so you're not threatened, but you're viewing it from a distance, but it is something which is awesome and you cannot really easily comprehend. So we thought that we would like to undertake such a study and show the subject. Again, all the experiments are done in a similar way. You show them scenes, and they have to tell you how sublime and how beautiful it is. So here is the Grand Canyon. And of course, we are aware of the fact that this is not quite the dramatic effect as actually going to the Grand Canyon, but it is pretty awesome nevertheless. And this is a tornado which is uncontrollable. And if you look at the papers, the book of Edmund Burke, he's got quite precise definition of what is sublime and what's beautiful. So if you ask your subjects to look at the relationship between what's sublime and what's pleasant in the images they saw, you find that there is up here a reasonable correlation between what's qualified as sublime and beautiful. There is a fairly flat correlation between what is pleasant and what is sublime, which is indeed exactly what Edmund Burke would say. And there's a negative correlation between the scale and sublimity. In other words, the larger the scale of the image, or perceived scale, the more sublime it is. All right? And this is exactly what Edmund Burke wrote in his book, A Philosophical Inquiry into the Origins of Our Experience of the Sublime and the Beautiful. And if you now look at the activity in the brain produced by experiencing the sublime in these pictures, we are very, very aware of the situation we're in. We're not taking them to Mont Blanc and to Grand Canyon. We're doing it in London in a scanner. So if you look at the activity in the brain produced by looking at the sublime, you'd find that it is distinctly different from the activity that is produced by the experience of the beautiful, which is so. I will not go into the details except to say that this is the part of the brain which is activity in which correlates with the experience of the beautiful, and this is the part of the brain, the activity in which correlates with the experience of the sublime. And there is no overlap at all. So in a way, again, and this is the beauty of reading what the philosophers of aesthetics and art historians have said, in a way, this is really giving teeth to their speculations that the two are very, very different. At the extremes, they indeed are. Now, the sublime has been related much more to constructions of the mind, of the brain, rather than to immediate visual input. And in his book on the critique of judgment, Immanuel Kant wrote that to be able to conceive of infinity as a whole passes any standard of sense. This is a direct quote from him. So he's saying it's something which is entirely generated in the brain. So we thought it might be interesting, just be interesting, if we were to look at what happens in the brain when people experience mathematical beauty. Now here you've got a very different crowd of people. They are mathematicians, in other words, they are very cultivated in mathematics. You can't pick them up in the streets at night. You've got to go to very determined mathematicians from departments of mathematics, and you've got to be very polite with them because they're very fussy people. And before you do that, you've got to collect equations which they can rate. So this is a study which it took 6 years to prepare, because mathematicians, of whom I had very good advisors, because I'm mathematically illiterate myself, told me, no, we can't accept this formula because it's got too much physics in it, and we can't take this one because it's too much chemistry. So they whittled it down, and we got it down to 60, and we got mathematicians. Now, it is important to emphasize that we got mathematicians who are not only English. We got Russian and Indian and English, British mathematicians, but they were all mathematically proficient in the sense that they were all postgraduate or postdoctoral fellows. And we gave them these 60 equations to take home and study and rate, and then they came back to the lab and looked at these same equations in the scanner and then re-rated them, so we again knew which ones they liked and which they thought were beautiful, which ones they thought were ugly. And you know, mathematicians, you must not underrate them. They become quite emotional when they see a beautiful equation. So, of the equations that the majority rated beautiful is this equation, which is Leonhard Euler's identity equation, which I'm afraid I'm going to have to read for you, because Euler's identity links 5 fundamental mathematical constants with 3 basic arithmetic operations, each occurring once. Now, a better summary was given to me by the preeminent mathematician of our times, Michael Atiyah, who said that this is the mathematical equivalent of the soliloquy in Shakespeare's Hamlet. So you can see the beauty that's being imbued. And the equation which was regarded by most, not all of them, but by most as being ugly, is, quite remarkably for me, Ramanujan's equation expressing the inverse value of pi as an infinite sum. Since the publication of this paper, some mathematicians have written to say that they find this beautiful, but that may well be so, but this is not irrelevant. It's irrelevant from our point of view, because we were looking at what our subjects experienced as beautiful at that time. I want to tell you a story which is, well, let me first of all show you what the result is. And the result will surprise me. I mean, if you look at great mathematicians like Hermann Weyl and Paul Dirac and Bertrand Russell said that mathematics possesses not only truth but supreme beauty. So what really amazed me was that when mathematicians experience beauty in an equation, you get activity in the same part of the brain which is in the medial orbitofrontal cortex. Now, let me just say that I rather enjoyed myself a bit, but I was angry for a while. It goes to show you how the editors who are responsible for publishing our findings, how they behave. When I sent this paper to Nature, it was sent back without review on the ground that it's not interesting. When I sent it to Science, it was sent back without review saying it was not interesting. And when I sent it to Current Biology, exactly the same thing happened. When it was published a year and a half ago, it has up till perhaps a month ago been viewed 103,000 times, including from countries which are war-torn: Ethiopia, Somalia, Iraq, Syria. So that puts in perspective how well able those who run our editorial affairs are able to tell us about whether a scientific paper is of general interest or not. So, having now got that bit out, let me just say a few words about mathematical beauty. It is true that the mathematical beauty, unlike visual or musical beauty, is derived from a highly cognitive source. And it is also true that the people who experience mathematical beauty are extremely well educated in a specific topic, so they are a special part of the population. And yet, mathematical language is universal. So whether you have been brought up in India, or whether you've been brought up in Russia and speak only Russian, or whether you speak only Spanish, once you understand a mathematical formula, you understand it. Immanuel Kant asked, what is it that is beautiful about mathematics? And he said, well, the formula makes sense. Now the question I want to ask is, it makes sense to what? It makes sense to whom? It makes sense to the logical, deductive and inductive system of the brain. And then you say, this must be right because it is beautiful. Now actually I'm not saying this. The person who's saying this is primarily Kant, but also Paul Dirac. Paul Dirac, who was a famous English physicist and mathematician, wrote, and I'm quoting it more or less verbatim, he said that the theory of relativity imported beauty into mathematics to an unprecedented degree. Before that, the guide to the veracity of a mathematical equation was its simplicity. But since the theory of relativity, the true guide to whether a mathematical formulation is correct or not is whether you perceive it as beautiful or not. Now that is not me, that is Paul Dirac. At one meeting actually somebody said to me, oh, you can forget Paul Dirac, he was autistic. Okay. Now, on the other hand, I want to tell you a story which is really quite striking, which is the story of Hermann Weyl and his formula. Hermann Weyl was one of the most brilliant mathematicians of the last century. And he always said that in my work I always try to combine truth with beauty. But when I have to choose between the two, I always choose beauty. You see, like Bertrand Russell, he's dividing truth from beauty. And I'm not happy with that. But anyway, that's what he said. So what he did was he worked for a long time on a mathematical formula to reconcile the electromagnetism of James Clerk Maxwell with the theory of relativity. And he came up with a formula which he thought was very beautiful, and he sent it to the journal to be published, and the journal sent it to Einstein for review. And Einstein said, you can't publish this, it's against all the known facts. So they sent it back to Hermann Weyl. He said, well, it may be against all the known facts, but it is beautiful, so publish it. So the editor, being, unlike the editors of today, being a wise man, said, right, I'll publish it with an index showing the objections of Einstein. And that's how it was published. And 10 years after this publication, with the advent of quantum mechanics, which Einstein never believed in, the formulations of Hermann Weyl were found to be all correct, and they're now republished without the objections of Einstein. So this is a very good example of the beauty of a mathematical formulation predicting the truth. So in a sense, I think I'm now entitled to ask myself, to ask you, to ask us all about what the functions of beauty are. Charles Darwin said it is sexual selection, which undoubtedly is, but is that all? Apparently not, because Plato in the Republic thought of mathematical beauty as the highest form of beauty because, he said, it tells us something about the structure of the universe. Well, with Plato it was sort of poetically stated, but when you come to more modern formulations, you find that there is a strong attempt to understand the structure of the universe through mathematical formulations, and the ones which are accepted are the ones which are found beautiful. And I'd like to leave you with the last story. I was at the World Economic Forum some years ago, and I was put in a session on mathematics. And this rather terrified me. So I went, my wife was with me, I went and said that, look, I'm not a mathematician, I think there must be a mistake. And she said, oh, don't worry, don't turn up. But my wife said, well, what kind of man are you? Are you afraid of mathematicians? So I said, I'll go. And I wanted to get my blow in first, so because to hog the discussion, because otherwise they would talk about things which I would not understand. I asked whether string theory, for which there is no experimental evidence, whether we would ever come up, whether humans would ever come up with a theory like string theory, unless we have the kind of brain structure that we have. Now, string theory is still controversial, it's not been settled, and maybe one of these days somebody is going to come up with a very beautiful formula which will finally settle the issue, or maybe somebody never will. But in that sense, I think that maybe the use of beauty is more than just sexual selection. It is arriving at truths which are not always immediately evident. Thank you very much.